Okay, grade 8s, last video, we'll call this part 3. And this starts on page 39. Okay. On Thursday, a snowboard was reduced by 20%. It didn't sell. Okay, so on Friday, the owner of a store reduced it by an additional 25%. If the original price was $7.50, what's the sale price on Friday? Okay, so take note. No mention of taxes, so we're not going to do taxes. So all we have to do is a two-step process where we're going to do percent of a number twice, essentially. Percent of a number the first time using 20% and the regular price, then percent of a number using 25% on that sale price from the 20%. Let's see what that looks like. Okay? So, step 1. What is 20% of 750? So 0.20 times 750. So I'm going to move a little quicker now because at this point I'm going to make maybe a small assumption here that you are really starting to get this. Okay? So that's equal to 150. So that's the discount. So the first sales price, 750 minus 150, that's equal to $600. Okay. So then step 2. Step 2. Now they're going to take the store owner is unhappy it didn't sell, so now they're going to do 25% off of 600. So what's 25% of 600? Okay, well 0.25 times 600. Okay, that's equal to, I already know it's 150, but let's just see if I'm right. Okay, so it's 150. All right. By the way, are you wondering why is it the same? Because here the percentage was less, but the price was higher. Here the percentage was higher, even though the price was left. And so it works out. It's no different from, I know it looks weird, but it's really no different from the concept of 2 times 6 is equal to 3 times 4. You know, one number goes up, the other number goes down. Okay? Because I know some people look at that and be like, well, how could it be 150? It's the exact same reason why 2 times 12, 3 times 8, 6 times 4 are all equal to 24. Okay, same idea really. Okay, so what's the final price? The final price, okay, the final sales price is going to equal, well, just take 600 now and subtract your 150. All right, sorry, that's supposed to be a 5. So the answer is $450. Okay. The Friday sale price is $450. Okay. Hopefully that helped. Okay, a town has a population of 12,832 people. 1 year, the population increased by 3.2%. In the following year, the population increased by 1.4%. What is the total population of the town? Okay. Now, just for some of you that like some of the shortcuts I've been showing, you absolutely positively cannot combine these percents because this percent is going to be based on this number, and then you'll have to get the new number for the new population and then do a percent of a number, this percent of a number on the new population. Here's the way I would do it. Okay, if you didn't quite get what I was saying there, I would just do, okay, I would just write, I would organize this so I'd say, okay, what happened in the first year? Well, in the first year, we're supposed to take 3.2% of 12,832 people. Okay, let's figure out what that is. So, well, let's translate. Don't get ahead of yourself there, Mr. Smith. Again, this is a critical moment for I won't say most, but for a lot of grade 8s because they'll mess it up. The fact that the decimal appears in a percent number sometimes messes people up. Don't let it mess you up. Okay, you're still punting the decimal place 2 places to the left. 1, 2. There it is. 0.032 times 12,832. Okay, what's that equal to? Let's see. okay, times 12,852. 411.264, round down when you're talking about people. It's either 411 like completely or 412 completely. The fractional amount doesn't exist. It's 411 persons. Even if that was 0.9, it's 411 persons. Okay? So 411 people. Okay, so what does that mean? Well, now you got to take your 12,832 people, add 411, and you get 3, 4, 12. Oh, look, my lights just went off in my classroom. 13,243, and that is done. Now, here's where I will do the shortcut. So the one shortcut that doesn't exist is don't add these percentages. But the other shortcut where I'm going to say, hey, for the second year, okay, for the second year, where the population went up by a positive 1.4%, can't I just take 100% of the prior year and add the 1.4% for the second year? And let's do 101.4%. Yes, you can do this. And we could have done it here. We just can't add these percents. But we can add this to 100%, add this one, and then it saves us this step. Let's see what this looks like. So 101.4% of 12,832 people. So that is 1.014 as a decimal. This number here is a percent. It's not a decimal. It's just a percent that happens to have a decimal to be accurate, right? To be precise, okay? Just like it would in real life. All these statistics we use to measure, they often involve decimal percentages. Okay, so regardless, let's just multiply this through. And now this time we should get the final answer without having to add it on, all right? So 1.014 times 12,832. Okay, so again, it's 13,011. This does not exist. Now, to satisfy those people who may be still skeptical, let's just do actually I'll do literally 0.014 times. So what is 1.4% of the population? 832. Okay, that's equal to an increase of 179. So let's take that answer and add it on to 12,832, and that's equal to, look at, the same answers. It's just that this involved two steps. This wrapped up this first line wrapped up together. Did you like that, Jester? It embedded, or it combined the steps. That's the best word I can think of. It combined the steps into one step. I'm going to take the original population, which is 1 times, and I'm going to take the increase, and it's going to be expressed as one number, and it'll get me the final answer right away. Or I could take 0.014. Okay, it obviously increased by 179 people. Yeah, ignore the decimal. And so what is that answer added to that population? It's the same thing. It really is the same thing. So what do we have? 13,011. 13,011. Okay. The total population after year 2, okay, I'm going to use POP as an abbreviation, is 13,011. Okay? Okay, I hope that helped. Okay, here was one that was requested quite a bit, all right? Because it deals with percent increase. And there's sort of an invisible number there that you have to be aware of. In Edmonton, the average amount of snowfall is 12 centimeters in December and 18 centimeters in January. What is the percent increase? Okay, great question. A lot of reading comprehension because you have to know what a percent increase is. All right. So let's have a look at December. I'm just going to summarize this information. December had 12 centimeters. January had 18. So let's just forget for the moment, temporarily, let's just forget what about the percent, okay? I'm literally going to cover that word up with my finger. What was the increase in snowfall between December and January? Well, from December to January, right? From December to January, there was plus 6 centimeters, okay? All right, I'll write that again down. I don't know if you can see the units, but anyways, there was an increase of 6 centimeters. So then what you got to do is you make a comparison. Make a fraction. Okay, make a fraction. Sorry, the word A is kind of close there. Make a fraction, make a comparison. Okay? So the increase, it's the increase over the previous month. Now, you don't have to remember that really in terms of, oh my gosh, is this some sort of formula thing? No, just apply some common sense here. It gave you a plus 6 increase over the 12 centimeters. December kind of established the denominator, established what are we comparing it to? Are we comparing it to, last year in January? Are we comparing to last year, July? No, we're comparing the increase to the prior month, okay? Compare the increase to the prior month. If this had said November, it'd still be the same thing, okay? You're comparing the increase to whatever the last thing was. In the case, the last thing in this case was the December snowfall. Okay, in other words, if you get 6 questions right on a quiz out of 12, what's that equal to? 50%, or 0.5, okay? So the percent increase is 50%. Okay? 50% more snow fell in January than December. Okay, and I think for some of your classes, I end up doing like a, on-the-spot improvisational chart, and I kind of showed you to help you wrap your head around it. Feel free to ask me again about this question, all right? But I'll leave it for now. Hopefully that helped. Okay, car dealer reported a 6.5% drop in sales. Drop. Do you think that's a good thing? Okay, is a drop a good thing, or is it not a good thing? Okay. A car dealer reported a 6.5% drop in sales from 675 cars. How many cars were sold? Okay, if I were redoing this question, I would have said, kind of like the last question, I would have said, say, it sold 675 cars in January, and then in February it dropped 6.5%. How many cars were sold in March or something? You could add a time frame here is what I'm saying. But nevertheless, on the other hand, you really don't need it. Let's just find out. What is 6.5%? Now, just keep in mind, so by the way, the answer here is no, that's not a happy thing. Okay, we're thinking subtraction. So just keep it kind of in your pocket here. Like just set it aside and think. Remember, we're expressing some negativity here, okay? Now, for the calculation, you can always think of this, look, I think I need to subtract later on, but for now, let's just do it as a regular, truly just a regular question. What is 6.5% of 675? There's 3 parts to it. Don't touch the last number. Hopefully I'm sounding like a broken record. Now, again, grade 8s, this is not a decimal number. This is a percent number because it is a percent sign, and it just happens to have a decimal, okay? So now we're going to move the decimal 2 places to the left, or in other words, divide by 100. In other words, 6.5% expressed as a true decimal, not a percent that just happens to have a decimal place, but a true decimal, okay, is 0.065. Let's figure out what that is. 0.065 times 675. Okay, so again, no, they didn't, you know, this, you have to round this number down. Say, so cars, like, this is real life math. So what was the last whole car that they didn't sell? In other words, like, how many cars less did they sell? That's what we're finding out here. It's 43 cars. It's not 44. You can't just round up. So 43 is your answer. Okay? 43 less cars. That's what this number signifies. Okay? Okay, so how many cars were sold? So cars sold, all right, is going to equal 675 subtract 43, not 44, 43. Okay, so that's a 2, 3, 6. So 632 cars were sold the next, I'm just going to go with month or the next time, but this, I really think this should have a time frame on it, but that's okay. All right, 632 cars were sold the next month. All right. Okay, I do love these last two questions because they get you to compare, and it really starts to kind of stretch your brain. And some of it, I would say, is kind of obvious, especially when you exaggerate your numbers. But let's see what's going on here. Which option do you think is best? Argue your opinion using mathematical reasoning. You can show your thinking in a variety of ways. Okay. Well, let's actually just do this. Okay. Let's do a versus here. Okay. Let's do a comparison. All right. Well, this one's easy. Like, okay, so this is, you know, I don't know. We'll call it scenario. Okay, scenario 1. Okay, you have a purchase of 105, and you're going to take away $30. It's a $30 coupon. It's not a percentage. It literally is a gift card for $30. So what are you left with? Okay, you're left with 75 bucks. All right, that's done. Now, use a 30% off coupon. All right, I won't do this the quick way. Let's figure out what 30% of $105 is. Okay, let's figure what that is. 0.3 times 105. Okay, that's equal to, so 0.3 times 105. That's equal to $31. So look, this one's the better deal, right? This one's going to be, because look, did you get to deduct? Did you get to save more money here? This was a gift card for 30. Here the savings is $31.50. Okay, so if you actually end up doing the, you know, subtraction here, you can clearly see minus $31.50. Okay, so it's pretty close, eh? Like, it's pretty close, but you do end up saving more. I'm just going to quickly show you something, though. In the end, okay, percentages are the better deal. Are the better deal. Most of the time. The better deal most of the time. Okay? So, like, just exaggerate this number too, and you'll really understand it, like, instantly. Let's say it's one of those expensive luxury cars, and they're like $300,000. Now, let me ask you, okay? Do you want 30 lousy stinking dollars off that price? Or would you rather save 30%? Whoops, I used the wrong sign there. Would you rather save 30%? Would you like to take off 30% of that price? Obviously, this is the winner, okay? So unless the item is like really cheap, like dollar store items, then most of the time you're better off using a percentage. Like, hopefully you'll be able to discount using a percentage, all right? Just a little fun fact from real life math there. Okay, last one, grade 8s. Hopefully the rendering, you know, the video when it gets processed, hopefully it's good, because I'm definitely not re-recording it at this point. Anyways, last question, which I kind of got wrong in class. I can't remember which class it was, but they when we looked at this right away, before we started calculating, some students said they're the same deal, and I said no. Well, Mr. Smith was wrong, and the students were right, and I made a colossal simple error. In other words, I ignored common sense, and that was not, that was not correct. Anyways, when you're doing a comparison, like this question came close. You see this? It came close, but the teachers, we're a little cheeky here. We chose $105. Now in this case, we didn't give you a number to work with, so why not just work with the easiest number in the world, right? Why not work with $100, because percent is based out of 100, and so if you have a $100 item, the mental math comes into play, and it's super, super easy. So here's what I mean. The regular price is $100. Okay, the first discount, which I'll just put as DISC. Okay, so you're going to minus $40 off, okay? Because that's the same thing as 40%. Okay, minus 40%. All right, so your new price, okay, your first sales price, okay, SP, first sales price is $60. All right, keep going. What's the second discount? The second discount is, now it's not quite as easy as 100, but it's still fairly easy. It's 30% of 60, so that's 0.3 times 60, and that's equal to 18, okay? So last question, guys. I'm invoking my privilege to go fast because I'm good at the mental math. So the final price, the final sales price is equal to 60 minus 18. That's equal to 42, okay? Okay, sorry, I was off the screen there. The final sales price is 60 minus 18. Just going to zoom out a bit so I don't have to worry about that. Is 42. All right, now let's compare. Regular price. Again, start with $100. You have to make a fair comparison, right? So you got to start at the same place. The first discount is equal to minus $30, right? Because why? That's $30 is the same as 30%. It's a $100 item. Okay, so this time, the first sales price here is higher, isn't it? It's $70. Looks like there could be a mismatch. But, on the other hand, the second discount, it's higher. Pardon me, it's higher. Here the first discount was 40. Awesome. We love taking 40% off. Oh, it was only 30%. But now the second discount is 30%, whereas here it's 40% of 70. Okay, so that's 0.40 times 70. That's equal to, see, this was only 18. Here it's what? 28. The final sales price, okay, is equal to 70 minus 28. So look at this. This price is $10 cheaper. This is $10 more. But the discount is $10 less than this one. So guess what it works out to be? 42. Okay? So they're the same. It's the same deal. Okay? Okay, grade 8s. I hope that helped. I'll be available for questions on Monday. You can email me if you like. I don't know how reachable I will be tomorrow on Sunday because I'm trying to do some marking. But nevertheless, keep studying and good luck.